This lesson is about animation. As we go through the example program, you'll find that the form is a bit clumsy in spots. That's because I'm leaving out a few things to show you the fundamentals of animation, and we'll be filling in these spots in the upcoming lessons and examples. Now, this program is a very rudimentary form of animation. It just moves a black circle across the window, and when it gets to the right, it pops back to the left and starts over. On top of that, the smoothing code has been left out, so it flickers as it moves, but it has all the fundamentals. Here, let me show you. First, let's take a look at the main line of the program. This is a frame that's laid out the same as the programs we've been looking at, but it has a couple of extra method calls. Once the canvas has been constructed, a call is made to the init method. The init method is sort of like an after constructor. It doesn't serve much purpose here, but later on, when we get to applets, you'll see where it becomes necessary. The call to the start method is necessary. This is the method that starts the animation running. There's also a stop method that halts the animation, but we won't be doing that quite yet. Everything else in the main line is the same as we've been using. This is a canvas that does animation. There are lots of declaratives at the top, but I kept these to a minimum by keeping the animation simple, but they all have a purpose, as you'll see. The constructor works the same as most of the previous constructors and just sets the size of the window. And this is the method init that's called right after the constructor. In this example, it initializes the background and foreground color settings. This method is not absolutely necessary in this example, but it's going to come in very handy later when we get to applets. More about that later. The start and stop methods can be called to start and stop the animation. If the Boolean value running is set to true, then a looper object has been created and the animation is currently running. This looper thing is the key to animation. Now, here's what happens. A thread is created with this object as the program runs. When the run method of looper is called, it calls the run method of the object it's supposed to run. It stays in existence until that method returns. Then it dies and quits and the thread goes away. But here's a special something it provides. When you call the run method of looper, it does two things. It starts a new thread of execution running, the one that calls the running method of this object, and it also returns to the original caller. That is, the looper goes off on its own and runs its own thread of execution. That way, we can manage the execution of the animation without having to worry about blocking anything else. Now, here's the run method that's called by the thread started by looper. It has a loop that continues to execute as long as the Boolean running it is set to true. All that happens in this loop is the value of x current is incremented. That moves the animation sequence to the next frame. Then it calls repaint to force the display to be updated. If x current reaches the far right side of the window, it's popped back to 0 over at the left. After this is done, the thread sleeps 20 milliseconds and then does the whole thing again. The exception is there just to catch an error condition somewhere in the execution of the loop. Okay, this run method is sort of the heart of animation. If you see how that works, the rest of everything will fall into place. If you don't quite get it, you might want to go back in this lesson and look it up and go through it again. If this is completely alien to you, you might want to study up a bit on computing threads. It's fundamentally simple, but it can leave folks confused at first. I have been telling you all along that a call to the repaint method would cause a call to the paint method. And that's true, but it isn't the whole story. A call to repaint actually schedules a call to update. The default update method just makes a direct call to paint, so it was only a sort of a lie. But this program replaces the default update method with its own update method, which does some other things and then calls paint. Same result, but with some added features. At the top of the update method, the current window size is returned with a call to get bounds. It's returned as a rectangle object, and this rectangle is compared to the locally stored rectangle. If there is any difference, the locally stored rectangle is replaced and all the local position variables are initialized. We are now ready to start the animation from scratch. The first time through here, the rectangles can't possibly match, so everything is initialized at the beginning. At the bottom of the update method, if the animation is running, a call is made to paint to display the window. The paint method just fills the whole window with a gray background and then fills in a circle at the right location. This location is going to be moving across to the right, so it will be in a different place every time this method is called. And that's the fundamentals of animation. We'll be cleaning things up a bit by adding some things as we go, but that's basically it. Now, here's what it looks like. Here it goes. A black circle proceeds from left to right. When it hits the edge on the right, it pops back to begin all over again. This is simple animation, but it has a problem. I don't know whether it records this way or not, but on most systems that run this program, the black circle flickers instead of moving smoothly and easily across the screen. In the next lesson, we're going to fix that flicker.